Hello and I want to welcome you to combinations of functions. So let's get started by looking at what that is. Okay, for this kind of section, you're going to probably be asked to find the domain. If a function does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. Exclude from a function's domain real numbers that cause division by zero and real numbers that result in the square root of a negative number. So for this example, it's from the domain of the function. All you have to do for these kind of problems are to start off by just taking the denominator for this first one, with the f of x is equal to x plus 3 over x plus 1. You just take the denominator, x plus 1, and set it equal to 0. Then you have to solve for the variable. So to do that, just subtract 1 on both sides. So you're going to get x equals negative 1. Okay, when x equals negative 1, you're going to get division by 0, which we do not want. So what you do, cross out the number that it cannot be, the 1, and you say now that the domain is anything from the negative infinity up to 1, a negative 1, excuse me, union by everything with the negative 1 excluded to positive infinity. And that is the answer to that problem. Okay, looking at number 2, let's just take the f of x equals x minus 9 over negative 4 plus the square root of 4x. So what you do, you take the denominator of minus 4 plus the square root of 4x, set it equal to 0. Now to solve for the variable, add 4 on both sides. So you're going to get the square root of 4x equals 4. To solve for the variable even further, square both sides to get rid of the square root. So you're going to get 4x is equal to 16. Now finally, to solve for x, divide by 4 on both sides. So you're going to be left with x equals 4. So when you let x equal 4, you're going to get division by 0, which we do not want, so we have to cross out the 4. So like before, to do our domain, we're going to have everything in the negative infinity direction up until 4, which is not included, union by 4, which is not included, then everything in the positive infinity. And that is the domain of that problem. Looking at number 3, have f of x equals 2x plus 5. This is a very interesting problem because no matter what you put in for x, you can always get an answer that is never undefined. So that just means that all real numbers will be the domain. With number 4, f of x equals the square root of x plus 12. So what you want to do is take what's under the square root, leaving the square root behind, just x plus 12, and set it 0 on the right side, and the operation between the two will be a greater than or equal to. Now just solve for the variable by subtracting 12 on both sides. You're going to be left with x is greater than or equal to negative 12. So to write that in function notation, since we have the equal to and then equality, we're going to include negative 12. So we have including negative 12, comma, positive infinity, close parentheses. So that is the domain of that problem. Moving on, the algebra of functions, sums, difference, products, and quotients. Let f and g be two functions. The sum, difference, and product and quotient are functions whose domains are the set of all real numbers common to the domains of f and g. So here are the operations and their functions, and we're going to explore them further. Okay, so we're asked to determine what f plus g, f minus g, f times g, and f divided by g mean. Then we have to determine the domain for each function. Okay, so let's get started. So f of x is going to be 2x plus 1, while g will be g of x equals x, or 3 minus x. So let's get started. So f plus g, all we have to do is write what f of x is, and I like to write it in parentheses. So parentheses 2x plus 1, and our operation is plus, which is right here, and we just write the g of x function, which is 3 minus x. The next step is just to remove the parentheses. So we have x plus 1 plus 3 minus x. Now we want to bring together like terms. So we will have everything with an x, which is the 2x minus x. This leaves us with x. And we have 1 plus 3, which is plus 4. So what does x plus 4 have as a domain? The domain will be negative infinity to positive infinity, because what we put in for x will work as an undefined, will work as a defined function. Okay, looking at f minus g, what we want to do first is write the f function, which is 2x plus 1. Notice I wrote these in parentheses, and we have our operation, which is minus, open parentheses, and write the g function. Okay, now what you want to do is distribute this negative across everything found inside the parentheses. So we just write our same problem of x plus 1. This time I dropped the parentheses. So negative 1 times 3 is just negative 3. And negative 3 times negative x is just a positive x, because a positive times a positive is a positive, and a negative times a negative is a positive. Okay, now to bring terms that are similar together, we have 2x plus x gives us 3x. 1 minus 3 will give you minus 2. So we have simplified, so now we need to do the domain. The domain of this problem will again be negative infinity, positive infinity, with a comma separating the two and ending and beginning with parentheses to show that the negative infinity is not included. Okay, now we have the function, a combination of fg. That means we're going to multiply the two functions together. So to do that, write each function in parentheses. So first writing the f, so we have in parentheses 2x plus 1, close parentheses, open a new set, and write g, which is 3 minus x. Operation is multiplication, and you will get the same thing of f and g if you were to do g and f, because multiplication properties yield that solution. So let's go through and use the distributive property. We're going to multiply the 2x and everything in the second set of parentheses. We're going to take the 1 and multiply it across everything in the second parentheses as well. So to get started, we have 2x times 3 plus 2x times negative x. So we've distributed the 2x across everything. Now we're going to take the plus 1 and multiply it by the 3. And now positive 1 times the negative x, found in the second set of parentheses. Now let's go through and simplify. 2x times 3 is 6x. Okay, and then 2x times minus x is a negative 2x squared. Okay, and we have 1 times 3 is 3. Okay, and finally we have 1 times x, a negative x is just negative x. So to bring this together, we will have the negative 2x squared plus 5x plus 3. And as you know, or you will learn later on in the class, this is actually a parabola that opens downward. And the domain of a parabola, since it has the x squared, the domain will be yet again, parentheses, negative infinity, comma, positive infinity, close parentheses. So finally we have f over g. For f over g, let's start off by writing the f function, which is 2x plus 1 over 3 minus x. Okay, now what you want to do is take the denominator of that rational function and set it equal to 0 and solve for the variable. So you just subtract 3 on both sides. So you have negative x equals negative 3. Now to make this a positive x, just change the sign. It's kind of like multiplying by a negative 1 across or dividing by negative 1 across. When you do that, you're going to get x equals 3. So that means that the domain cannot equal 3. So the domain is x is not equal to 3.